The next section we're going to cover is fairly straightforward. It has two formulas for you to memorize, and then the application problems that go with those, and that's the law of sines. The law of sines is used anytime you have an obtuse triangle. Anytime you have an oblique triangle, which means the triangle is either obtuse or acute. And the law of sines has two forms, and it says that the sine of an angle compared to its opposite side has the same ratio for every side and angle pair in a triangle. So the sine A over the length of A equals the sine of B over the length of B equals the sine of C over the length of C. And because this is a proportion, I can flip all parts over. So I can get A over the sine of A is equal to B over the sine of B, which is equal to C over the sine of C. So if you're given two angles and a side that matches one of the two angles, so if you're given 3 out of 4 pieces of information in one of the proportional relationships, you will use the law of sines. Okay? You need to have 3 out of the 4 so you could set up the relationship. If you're given 2 angles and a side, you'll directly solve for a side just using regular trig functions. If you're given 2 sides and an angle, you'll end up taking an inverse trig function, which I will show you in the examples. One thing I want to warn you about is anytime you're given 2 sides and then the adjacent angle. For example, if I give you little a, little b, and then angle A, there's a possibility that you can end up with 2 different triangles. So you need to take into account when you're working with the law of sines and solving triangles that there could be a possibility that there are 2 triangles that meet the condition. So my first example I'm going to do, we are going to say that little a is 12, little b is 31, angle A is 20.5 degrees, and the directions are to solve the triangle. So what I realize here is that I have 3 out of the 4 pieces of information here. So what I'm going to do is I'm going to write the law of sines with the angles on the top so that I can solve for angle B. So that will be this version of the law of sines. And I am now going to fill in the blanks. It tells me that the sine of 20.5 degrees over little a is 12 is equal to the sine of B over 31. And now I want to solve for B. So to solve for B, I multiply both sides by 31. So that gives me the sine of B is equal to 31 times the sine of 20.5 degrees divided by 12. But I don't want the sine of B, I just want B. So in order to find B, I am going to take the inverse sine of both sides. And then that'll tell me what B is approximately equal to. And I'm going to round to 1 decimal point. Remember, the inverse sine of something is going to give me an angle. Make sure you are in degree mode in your calculator. So I'm going to do the inverse sine of the fraction 31 sine 20.5 over 12. And it gives me approximately 64.8 degrees. Now here's one thing I want you to realize. If I draw my coordinate plane like it's on a unit circle, 64.8 degrees, something like this. Okay, and I know that there is another angle that has the exact same sine as 64.8 degrees, and that would be the one that's in quadrant 2 right here. And it's going to have the exact same reference angle. So this angle right here, the possible second angle, is 180 degrees minus 64.8, which is 115.2. And if I look at both 64.8 and 115.2 and add it to the 20.5, add them to the 20.5 degrees that I had for my original angle, each of these is a physical possibility. So when it comes time for me to solve for the third side of the triangle, I have to take both of these into account. So when I do this, I'm going to write 64.8 degrees as a possibility. Then I'm also going to write 115.2 degrees as a possibility. And then what I'm going to do is figure out the measurement of the third side of the triangle. So 180 minus 20.5 minus 64.8 is, C could either be 94.7 degrees or 180 minus 20.5 minus 115.2, or it can be 44.3 degrees. So now I'm going to use both of these relationships here and the original fact that I was given, so I didn't have a calculated angle, and I'm going to be able to solve for side C. Note, I'm going to have to do it twice, and this time I'm only going to use regular trig functions. So what I'm going to do is write C over the sine of C is equal to A over the sine of A, or C over the sine of 94.7 degrees is equal to 12 over the sine of 20.5 degrees. To solve for C, multiply both sides by the sine of 94.7. And divide by sine of 20.5. And for the first possible side length of C, I get fraction 12 sine 94.7 over sine of 20.5, and 34.15 is a possibility. And the other way I would solve it is I would put a 44.3 degrees here. So I'm just going to change this one to a 44.3 degrees, and that will give me the other possible part of the triangle. 4.3 and 23.93. And whatever the associated units are. So the only time that you're going to need to worry about there being two angles is if they give you two sides and the non-included angle. Okay? So that's the first example. I'm going to pause, erase the board, switch my microphone, and get you a second example. So the next example is like many of the homework problems. They're just going to give you either two angles and a side or two sides and an angle, and then tell you to solve the triangle. And when it says to solve the triangle, they mean come up with all three sides and all three angles. Okay, and what you need to be aware of, there may be a problem or two where a triangle will not exist, and you're going to be able to figure that out as if you get the sum of the angles of a triangle or a potential triangle are more than 180. Okay, so first thing I'm going to do is look at what I have. I have A's and C's, okay, and I'm solving for little a, so that's the form of the law of sines I'm going to use. I'm going to write A over the sine of 24.3 degrees is equal to little c, 2.68, over the sine of 54.6 degrees. Multiply both sides by sine of 24.3. Okay, so I get clear 2.68. Let's do a fraction. 2.68 sine of 24.3 over sine of 54.6. And I get 1.35. The next thing I know is I need to come up with this third angle, and you're going to use the third angle theorem that says that the sum of the angles in a, well, you're going to use the triangle sum theorem. Sum of the angles is 180. So 180 minus 24.3 minus 54.6. This is 101.1 degrees. And what I'm going to do is everywhere that I had an A here before, I'm going to replace it with the B stuff. So I have B is equal to, these two parts are going to stay the same. But here I'm going to have the sine of B, 101.1 degrees. Again, you can rewrite it all out. I'm just using the fact that I'm going to do the exact same math arithmetic over again to get solve for B. So I'm going to go up to my previous equation and change my 24.3 to a 101.1. And I get 3.22. Actually 3.23. So again, the law of sines is just about using proportional relationships. And you need to remember that if you're given two sides and the non-included angle, you have the possibility of ending up with two triangles. The other application type problem with the law of sines is area. And this is an area formula that I would memorize because it comes in very handy, and I'll show you the application of that. The area of a triangle is equal to 1/2, and it's the product of two sides, so AB, and then the sine of the included angle. So 1/2 AB times the sine of the included angle, or 1/2 BC times, so BC times the sine of the included angle A, or 1/2 AC, that's these two sides, times the sine of the included angle B. So that's how you'd be able to calculate the area of a triangle. And the one where this comes in really handy is if you want to figure out the area of the triangle that makes up a sector of part of a circle. For example, if I have a circle here, we're going to call this 50 degrees. Let's say it has a radius of 10 inches. Well, we know we can find the area of the sector, which is the whole piece of pizza. But let's say I want to find the area of that triangle. Well, if this is the radius, this is also the radius. And I know that the area of the triangle is going to be 1/2. Well, 10 times 10 is 100. Times the sine of 50 degrees. So my area is 50 sine 50, approximately 38.30 square inches. Okay, well, we also know the area of the whole piece of pizza. The area of the whole piece of pizza is pi times radius squared times the fraction of a circle. So this is the triangle. This is the sector. So I'm going to do pi times 10 squared times 50, divided by 360. And that's approximately 43.63 inches square. And because I know the area of the whole piece of pizza and the triangle portion of the pizza, I can find the area of the crust by subtracting the triangle from the sector. So I'm going to call it the crust area is approximately 43.63 minus 38.30, approximately 5.33 square inches. To me, this is a very, very handy formula for area of a triangle. So as a review, law of sines, just 3 sets of proportional relationships. You need to have 3 out of the 4 pieces of a pair of the relationships together in order to use the law of sines. If you can't use the law of sines based off the pieces they give you, you'll use the law of cosines, which we will go over on the next lesson. And then you need to know the area formula. And the area formulas are 1/2 the product of 2 sides times the sine of the included angle. And again, instead of memorizing them like I have here, memorize them in words. It's 1/2 times the product of 2 sides times the sine of the included angle.